So we're talking about derivatives using a limit. So let's do one. Let's do a tough one, okay? So we'll say f of x is the square root of 1 minus 2x. My shortcut here is actually called something called the chain rule. My shortcut is the chain rule. You're not ready for this. This is in section 3.4. This is when I usually lose a couple of students, if I haven't lost you already. So by the chain rule, which we haven't learned yet, f prime of x is 1 over 2 square roots of 1 minus 2x times another negative 2. So we get a derivative of negative 1 over square roots of 1 minus 2x. You can see, you remember my shortcut for square root of x, right? You remember my shortcut for square root of x. If y equals square root of x, we had y prime is 1 over 2 square roots of x. So you can kind of see that in my version here, right? You see it? It's a square root, right? So there's my 1 over 2 square roots, right? And then where is the slope the inside? This is the essence of the chain rule. You're not supposed to understand it yet. Let me teach it to you after our midterm. Okay? Oh no, before our midterm, sorry. Because it's in chapter 2. Sorry about that. I just have it on in case anybody uses remind. So we want to do this one with a limit, yes? So we want f prime of x is the limit as h goes to 0 of the original function evaluated at x plus h, notice I use parens, minus the original function all over h. How are we doing here? Homework on the back table when you get settled, okay? Now this one, I want to work on this inside function because it's too messy. I like to get rid of parentheses most of the time. You'll kind of discover when you want to and when you don't want to just by doing a bunch of problems. And this one I want to. And I'm going to use my conjugate, right? Square root of 1 minus 2x minus 2h plus square root of 1 minus 2x. All of that over itself. How's everybody here? So I was plugging in 1. I was plugging in 1 on that first problem. Oh my God. Thank you, Ryan. You saved me. What number am I supposed to plug in for x? 2. 4 times 2. 2 times 2 is 4 minus 1 is 3. 3 times 8 is 24. Thank you. You saved me a headache. All right, so I'm going to distribute upstairs, and I get the first argument squared minus the second argument squared. Be careful about parentheses. Right? Be careful about parentheses. Joanne, the homework on the back table there, okay? Everybody okay with me here? Can I plug in h as 0 yet? No. So this is not my replacement function, right? This is not my replacement function. If I plug in 0 here, I get a 0 downstairs. And I get a 0 here, and then look at everything else just cancels, right? So if there's any place to maybe take a little bit of a shortcut, it's right here. I can see the ones are going to cancel, right? And the 2x is going to cancel. And then I'm trying to take my time here. I've got minus 2h all over that same thing. And yes, it's annoying, but so is life. So get over it. Every time you write the next line, it's a complete sentence. Don't keep putting up partial thoughts. Don't do things in your head. Everything is a baby step. Everything is on paper. My h's will cancel. And I get minus 2 times the square root of, or all over that conjugate. How's that? That's my secant slope for what? Any x that's in the domain, right? And any h that keeps being in the domain. So I want to do f prime of x. Am I zooming too much? Is it too hard to see? No, it's okay, right? Just don't zoom anymore, Robert, right? Is the limit as h goes to 0 of star. Yes, I can do that. I'm allowing you to do that, right? This is my replacement function. I can see if I plug into 0, this goes away, right? So I get 2 over square root of 1 minus 2x plus another square root of 1 minus 2x, right? And that's 2 of them. Oh, negative 2, right? And there it is, negative 1 over square root of 1 minus 2x. There's my derivative. I think the kind of interesting thing that's happening in this one, remember I said it's chain rule, right? The chain rule is section 3.4. That's where it gets tough. Right? You really want to make sure you have work done up until 3.4. When I get through 3.3, you should have that homework completely done before I start 3.4. Okay? Then the chain rule happens for the rest of your mathematical careers. So if you never get it in Calc 1, forget it. Okay. So, but the interesting thing that happens here is almost every function I've been dealing with so far, right? Is this okay? Can I move? And move off this page? I am recording. Yep, I am recording. Yep. What's interesting that what happens is if I think about like square root of x, right? I get my slope, right, from what? 1 over 2 square roots of x, right? Slope at any point on that curve, I'll get from 1, you remember doing this, right, on Thursday? And what happens is, if I move this thing over like this, what's my function now? My pre-cal students should know here. I move it over that way to 1. It's inside my argument. So, what number would make the inside 0? What number makes this inside 0? 0, right? What number would make this inside 0? Not negative 1. 1. So I need to shift this by x minus 1. Remember x's behave inversely. So what number can I plug in here to get me back to a 0? 1. So there's my 0 again, right? So on the inside, if I'm subtracting, I'm moving right. Well, guess what? These two lines have the same exact slope. Just because I moved a function over didn't change the slope of my skis on the hill, right? I moved the whole hill over, right? So what's y prime in this case? 1 over 2 square roots of x minus 1. If I'm just doing a translation, just sliding it over, or sliding it up, or sliding it down, but don't change the shape of the curve, I can just think of these slopes as the same, right? Is this making sense at all? So you should do, on your own, this derivative and this derivative and show that they're the same, that they're exactly what I have on the page. Now, what did I just do? I had y equals square root of 1 minus 2x. I've changed the shape of the function. This is what I would call a transformation, right? Like Rock'em Sock'em Robot Transformers, whatever stupid thing that was. It changes the shape of it, right? So that's going to change the equation for the derivative. So watch what I mean here. So I'm going to say y equals square root of a plus bx. And I want to make a 0, and I want to make b 1, yes, right? So there's my square root of x, yes? Don't get too confused by it. Right? But a is 0, b is 1, so it's square root of x, yes? If I let a go to minus 1, right, watch what happens to my graph. If I let a go to minus 1, you see my graph moves right. But when I change the value of b, now what's the slope inside here? 1. So the key is, whenever I have an interior slope of 1, my derivative function is only going to change by the same shape that the function changed by. The same transformation, right? So, but if b becomes something different, watch what happens to the curve now, right? If b becomes 2, look what happens to the curve. You see it's changing the slope on the hill. So that's going to change my derivative function. Now, you don't need to think about that yet. All you have to do is do that process with the limit. And do the algebra, take your time, make sure you're careful, right? But as we move to the chain rule, we're going to be noticing what's the inside function. What's the slope of the inside function, right? So that's coming up. In fact, what if I had y equals square root of x plus 3? What's y prime in that case? One over 2 square roots of x plus what? 0. The derivative of 3 is 0. Right? The slope of a line y equals 3 is a horizontal line, so the derivative is 0. So what am I saying? If I've got some kind of shift in the horizontal direction, my slope, my derivative doesn't change. Right? It's the same 1 over 2 square roots of whatever is inside. And if I have a shift in the vertical direction, it doesn't change at all, because it just moved the mountain up. It didn't change the slope of my skis when it moved up, it just pushed my skis up, right? Pushed the slope up. Still the same slope, right?
So like the 2 came from like the square root, I can write it down.
Well, you know, if you want to talk about the shortcut, yes, it's square root of x is a 1/2 power, right? So that 1/2 comes down. Yeah. All right, let's do another one. Let's do one with a tangent line. Let's see, y equals 1 over x squared. What's my shortcut here? Negative 2 times x to the negative 3, right? I'm subtracting 1. So I get negative 2 over x cubed. There's my y prime. Okay, you ready? Are we okay? Shortcut bothering anyone yet? So this one's a power rule. Whenever I have x to some power, right? So I've got x to the minus 2. You're okay with this line here? Go ahead, yes? Right? Negative exponent is reciprocal, so this one downstairs goes upstairs. Now I bring down the power. I'm going to multiply by negative 2. Then I'm going to subtract 1 from the power. So negative 2 minus 1 is negative 2. Good. Let's do it the long way. F prime of x is 1 over x plus h quantity squared minus 1 over x squared all divided by h. And I'm going to work on this thing separately. I'm going to call it star. If you remember, I said there's times when you want to get rid of the parenthesis. This is one of the times you don't. And you say to me, well, how am I supposed to know? I'm going to say, do a bunch of problems. Just the same way you learn what a dog or a cat is. No one can tell you. You have to see enough examples and then you know it. Like, look at that ugly dog. No, that's a hairless cat, right? I remember walking down the street with my dad, and I said, look at that cool truck. He'd smack me and say, no, that's a car. And that I got hit enough times that I started to realize what a truck or a car was. So, same thing's going to happen for you. You're going to get a little mathematical smack. I need an LCD, right? Yes, you with me? So I can see I have two denominators of x squared and x plus h quantity squared. And I'm multiplying by 1. Yes, you with me? Stop me now, please, or I have got my remind on if you need any kind of... Yeah, you can get an LCD, but this is so much quicker. So much quicker. I'm not going to mark you wrong if you get an LCD. I'm sorry, if you get a single fraction upstairs and then do keep, change, flip. But I'd rather you do it this way because of what's coming. So I get x squared over x plus h quantity squared over x plus h quantity squared. I'm distributing it into numerators, right? You should be racing me, not copying me. So the x plus h quantity squareds go away, the x squareds go away, and I'm rewriting and I'm taking my time, right? Rewriting, taking my time. Emerson, hey, morning. How are we doing here? Yep, don't let me roll you over. I'm your Uber driver. You can tell me how fast to drive. You cannot control my reading. What do I have to take care of first? The square or the negative? Square, right. Got x squared minus x squared plus 2hx plus h squared. Hopefully that one we have memorized now. Claire, make sure I'm not running off the edge here for you. Remember, when you rewrite your notes, you do this over yourself. You don't just copy the notes, right? Don't just copy the notes. Do it yourself, and then look and see what you got there. Or better yet, graph it with the tangent line and see if you got it right. That's what you're going to do on the test. Now I'm going to distribute this negative, right? But I really can see that the x squareds are going to go away. Notice that the only thing that's left has a factor of what? H, and if that doesn't happen, you made a mistake. Everything that's left has got a factor of H in it. I got lots of choices for my algebra. You don't have to do your algebra the way I do. But I'm going to just, right, I'm just going to factor out that H. How did I know not to manipulate the downstairs? So it's in that last line that's showing, that first line that's showing, how did I know not to FOIL this thing out? I mean, it could have, but it wasted my time. I don't know.
So you're gonna get the remainder.
I'm gonna let that H go to 0 later, but upstairs, why did I manipulate upstairs? Get rid of the fractions. Yes, get rid of the fractions. That's what I'm trying to do. Remember, my ultimate goal is single fraction numerator, single denominator, completely factored. I don't want fractions within fractions. So my H's will cancel here, and it looks like I've got my version of star I want to use. Yes.
Before you go on,
Yes.
so not this row, but the one with all of the x's. Yeah, this one. How did you get from there to the one with it?
Yeah, so I'm x squared minus x squared is gone.
Yeah.
And then I
then you factored
out the h. You could have distributed and then factored out the h. I don't care. Go in.
What is the star again?
What is it?
The star?
Over time.
The star. The little star.
Oh, that's what I'm calling it. You know, like George Foreman has 3 sons. They're all called George. I have total freedom. I can call this function whatever I want. I'm calling it star. Or asterisks, right? My girlfriend learned how to play guitar, and so she said, "What's C hashtag minor?" That's a joke. That's a sharp, C sharp minor. In music. No one plays music? She's Polish. She's a little bit. We're supposed to be dumb and smart at the same time. But the other day she said, "I'm so good at putting my contacts in. I can do it blindfolded." I'm like laughing, and she's like, "What's so funny?" Here we go. F prime of x is the limit as h goes to 0 of star, which is what? Negative 2x plus 0 over x squared times x plus 0 quantity squared. Everybody with me there? Notice that when I plug in the 0, I'm no longer writing limit, right? I'm taking the limit of a function. And I know now I can plug in, so when I plug in, I'm no longer taking a limit. I'm at the point. I'm at the bullseye. So what do I get? Upstairs I get just negative 2x. Downstairs I get x squared times x squared, right? So that's negative 2x times x to the 4th, or negative 2 over x cubed, which is what we got from the shortcut. Because I'm multiplying them, right? Yeah, so x plus 0 is x squared is x squared, x squared times x squared is x squared. What? Oh, the shortcut? Yep. Again, what's our shortcut? Y equals x to the n gives me y prime equals n times x to the n minus 1, except when n is what?
One,
Except when n is what number?
negative. 0, 1,
1. When the power is 1, it's an mx plus b, right? If y equals x, y prime is 1. This is when I get an mx plus b, my derivative is always the slope. Right? Yes. Now, my original function was 1 over x squared, right? What's everything? What number's not am I doing? 1 over x squared. No, maybe it's over. What's the domain of 1 over x squared? Everything but 0, right? So we're going to get a tangent line that's somewhere in the domain of the function. Notice the domain of the derivative. What's the domain of the derivative? Everything but 0. I can't get a slope at 0. There's no part of the function at 0. How the hell can I stand on the hill? Right? If there's no place to stand, I can't measure the slope of my skis. Is that making sense to everybody? You're watching the Olympics, the downhill? No? So I've got f of x is 1 over x squared. Anything in the domain except for 0, agreed? I've got f prime of x as negative 2 over x cubed. I know what my graph looks like. And if you don't, what do you do? But if you don't know what your graph looks like, what do you do? Put it on your calculator. Right? Someone pick me a nice value to get my derivative here. What x value are you interested in? Grace, what x value are you interested in? 2? 2? Nice. So 1, 2, I'm talking about this point right here. I want the tangent line right there. That's not a very good drawing, Robert. That's better. So I need what? To get the equation of this line, what do I need? I need 1 point. I only have an x. I need a y. I need to find f of 2. And then I have to find a slope. I need f prime of 2. Right? So the y is f of 2, which is 1 over 2 squared. That's 1 over 4. And the slope is f prime of 2. Everybody following me? Everyone okay? So negative 2 over 2 cubed. That's negative 2 over 8. That's f, yes, exactly. Right? F is a y value, right? So now my tangent line, right? Y minus 1/4 equals negative 1/4 times x minus 2. Everybody with me there? If you're a y equals mx plus b person, get over it. That's middle school. We're using this one now. Okay? I want to make it look as pretty as I can. So y minus 1/4 equals minus 1/4 x plus 1/2. And I'm putting that 1/4 over. Right? So I get Yep. Plus 3/4, right? And Claire, you're a cop. You're gonna pull me over and say, slow down, okay? I'm gonna first say, oh my God, I hate the cops. Well, I don't hate the cops, but when they pull me over, I hate them. Don't you have some drug dealer to go bust? One of my favorite lines from the movie Mickey Rourke called Bar. It's not that I hate the cops, I feel a lot better when they're not around. I feel the same way about my family too. All right, I want to go to Desmos. You're going to go to your calculator. There is a way to plot a single point on your calculator. It takes a little bit of work, a little bit of research. You need to use the stat menu. So you go plotting a point on a graph, TI 83 or 84, whatever you're using. Diego, you going to get a calculator today?
Yeah.
Good. Say again? Joanne, say again? Nothing?
No, I said that.
Oh, yeah. You can't use a calculator that will do derivatives or integrals for you, and that one does. So I had what? F of x equals 1 over x squared, right? I had the point, thanks to Grace, 2 comma 1/4, am I right? Nice. I got a weird parenthesis there, but who cares, right? And now I have the equation y equals minus 1/4 x plus 3/4. Boom. Oh man, it feels so good to be right. My girlfriend and I are arguing. I go to my office and I start doing math problems so I can be right every now and then. He says, you got problems. I said, yeah, I'm working on number 33 right now. Pretty cool, right? Feels good to be right. On your TI 83?
Yeah.
Google it. Not spending class time on it. It's just a whole bunch of buttons. Okay? You Google it and find it. You don't really have to. You'll be able to see on the graph that you're hitting at the right point. But it's just a nicer picture. For this next homework that's posted, the first 2 problems I'm asking you to do, it give me a picture like this. On the test, you're going to know you have your derivative right by checking like this.
Is it for the homework you send it with Desmos or you?
No, rough sketch. Don't OCD it, right? Don't be sitting there with a straight edge and, rough sketch. There's lots of programs that will do it for you, but I like Symbolab. I actually like Wolfram Alpha, which is it's a web version of a program called Mathematica. I'm looking for my derivative. There it is, derivative of 1 over x squared, right? And so there's the answer, right? It shows me the shortcut, right? It doesn't show me the whole process, right? Because eventually we're going to get rid of that whole process. We're going to have shortcuts for everything. Moment on all 5 problems for this whole program. You can do the shortcut, but I want to see the long cut.
The long cut is
The limit. The limit, yeah. No one calls it a long cut. It's a lot longer than the shortcut, right? the not so shortcut. Nice. What do you think? One more? Yes? No?
Yeah.
Now, in Chapter 2 review, there's a bunch of problems to do for derivatives. In homework 6, there's a bunch of problems for derivatives, right? There might be a time in that I say, or the book will say, use a shortcut and get the tangent line, but Yvonne?
So besides the squeeze still and then, formula you give us at the place, everything is on everything that we do.
The WebAssign is there for you to do as much as you want. You must register for WebAssign. Because if we have to take a test, if we get shut down and you can't take a test because you don't have WebAssign, you're going to get a 0. If you get a 0 on the midterm, you're pretty much screwed, right? You're taking a midterm and a final.
What I mean is like everything that we talk right now, all the material is covered in like the exercise.
Yep. WebAssign is there for extra practice if you want. The problem with the extra practice, problem with WebAssign, I can't tell if you're doing the limit the long way or you're just taking the shortcut. That's why I'm asking you to turn paper in. I want you to have this thing graded so you can hear my notes. So you can see, I see the limit notation I got wrong, right? It's a derivative, both are derivatives. One is using a limit, that's the long way. That's the way you should be practicing. And the shortcut is the shortcut. I see patterns, so I can figure out shortcuts. In fact, if I gave you the list of shortcuts right now, okay, y equals a constant, right, implies y prime is what? 0, right? Y equals c is a horizontal line, yes? Slope is 0. Y equals mx plus b. What's y prime? M, the slope, right? Notice the slope on a line is the same everywhere. So the derivative is the same everywhere. Y equals x to the n implies y prime is n times x to the n minus 1. Bring down the power, reduce the power. Y equals e to the x implies y prime is e to the x. This is a pretty damn special function. I'll prove it to you later. Every height of the function is the slope at the tangent line. Pretty interesting. Wherever height is, that's the slope at the same time. Y equals ln of x equals, so it gives me y prime is 1 over x. Y equals sine of x is, the derivative is cos of x. Pretty crazy. If y is cos of x, y prime is negative sine of x. I always remember that one by moving clockwise, right? And I'll write my alphabet A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, N, M, N, O, P, right? So cosine, derivative of cosine goes past the negative. You see it? Starting at cosine, the derivative goes past the negative. Cosine, past the negative to the sine, so there's negative sine. Derivative of sine, starting at sine, you don't go past the negative, so you just take the cosine. I think that's our main list of shortcuts right now. We'll keep adding. You only really kind of get the first 3, right? You definitely get the first one, right? Yeah, right, horizontal lines are slope zero. Oblique line, right, and that's supposed to be slope goes down, right? This one, why is the power reduced? Why is the power reduced?
Because the end goes down, so
See again?
the end goes down, that's the move down.
Yeah, but why?
So I think this is power reducing, I don't know, like the entire, like, the way that I would describe it to myself would be because the derivative of the function is always gonna be, like, so if the function itself were an exponential one, then the function could just be a linear. No,
I like
linear,
it,
but we're
but
gonna
why
do
does that,
linear.
I
Yeah.
like it, you got it, but why does it happen?
Okay.
What am I dividing by downstairs? Yes, H, but it's really what? Say again? One more time, just a little louder for me. Okay, better yet, instead of the change in x, how about just x? And what happens when I divide by x? Into x to the n? Reduces the power. Reduces the power. And Claire, to what you're saying, we're trying to take a curve and make it into a straight line, right? So we keep reducing by powers, right? We're trying to get to a line, because the line is easy, right? The line is very simple. In fact, with straight lines, you can see everything. That's what we're trying to do, right? With straight lines, you can see everything. Sketchpad. Where is it? RS. I can do the alphabet. Sketchpad with straight lines, I get beautiful, beautiful things. So I'm going to take a circle, pick a point inside the circle. I forget what I'm supposed to do. Don't tell me. Oh yeah. I want to construct that segment and then create a perpendicular. And then I want to trace. Uh-oh, made a mistake, sorry. Control Z, Control Z. I want to pick a free point on the circle and then construct that segment. I got a point. Eventually I'll get there. Construct segment, construct perpendicular, trace perpendicular, move my free point. Oops, wrong one. Move this point. And you can see I get a hyperbola. This is the cooling tower. Oops. No, I made a mistake. Anyway, you can see that my traces will give me other shapes, right? This is, you recognize this shape? This is where Homer Simpson works. This is the cooling tower of a nuclear power plant. Right? So, but just from straight lines, I can get very complex shapes. Right? I'm screwing up this sketch. I can't think of it right now. My brain is, I'm getting too old. Forget what I'm supposed to do. Doesn't matter. I'll think about it. I'll show you next time. Okay, let's do one more. Yes. Let's do a simple one. Let's see. Y equals 40x minus 16x squared. Recognize it? Yep, right, this is from the homework. We're gonna get the derivative. Do you already know what it is? What is it? What is it? Okay, that's at one point. I'm talking about in general. All right, let's find out. Well, we can take a shortcut here, right? 40 minus 32x, right? There's my derivative. How did I get to 40? How did I get to 40? This is an mx plus b, so the slope is 40, right? How did I get to 32x? 16 times the power, is 32, and then reduce the power by 1. 32x to the 1, 32x. And of course the negative is still there, right? Okay, f prime. Well, let's do it this way. Let's do f of x plus h, right? So 40 times x plus h minus 16 times x plus h quantity squared. When I have polynomials, I prefer to do this. I don't go right into the whole formula. I like to get the f of x plus h, then the f of x, then subtract, make it a quotient, right? So that's a 40, sorry. So 40x plus 40h minus 16 times x squared plus 2hx plus h squared. Again, you're probably not copying me here. You're just writing everything out yourself. Let me wait for you there. Make sure I got you. Yes, everybody okay? Now, f of x, I write with the idea that things are going to cancel, right? I got a 40x I'm lining up here, and negative 16x squared here, because I'm going to subtract them, and those pieces are going to go away. Notice that everything that's left has a factor of h. If it doesn't, you made a mistake. Everything that's left is a factor of h. There's my difference, correct? Because I'm subtracting, right? There's my quotient, because I'm dividing, yes? Let me just make sure. Thomas is not here. Starting to get worried. Diana, Grace, Rosie, Claire, Brian, Ian, Eduardo, Chris, not here, Emerson, Justice, Bahameen, Narnata is missed 4 classes, Diego, Don, Yvonne, Ryan, and Kevin. Everyone else is absent. I wonder if it's because homework is due. Oscar's here. What happens if you miss a homework? 0. If you miss a class when homework is due, what should you do? Email it to me, a single PDF, right? I want to factor out an h. And you can already see my derivative showing up there. Do you see it? You see my shortcut answer already? The blue is me saying, take this and subtract that. So this one goes away, this one goes away. So I just get now, that minus this is everything left.
But why did you do this?
Because that's the different portion, right? You can see here my limit.
Okay, yeah.
You don't have to do it that way. I just find it's a lot easier. So it looks like I got my star, right, which is 40 minus 32x minus 16h, right? And I'm going to let that limit as h goes to 0 of star. And what do I get? I get 40 minus 32x, which is what? I got for my shortcut. And of course, we're interested in that 1, right? If x is 1, f of 1 was 16, correct? Oh, no, 2, right? F of 2 is 16. And what's the slope at 2? It's not 16? Into the original 8? Yeah, 16, yep. So the slope, though, is 40 minus 32 times 2. That's 40 minus 64. That's negative 24. Recognize it. And then my tangent line is y minus 16 equals negative 24 times x minus 2. I know I'm going too fast. Sorry. I'll slow down. Just thinking about break. That's why we have most of our car accidents close to home, because you start to think about what's next. Right? When you make people dinner, what are you going to eat? Did the dog piss all over the place? You start thinking about driving. The same thing we do. Too much in a rush to get to the next line of what I'm working on, I make a mistake. What is it, 54? 64? 64, yeah. All right, let's take a break. Yep. Let's come back at 10:15. See it, but the shortcut is the same as what we got. Right? 40 minus 32x is our shortcut. What's that? No. Calculator? Oh, no, just your names on everything. I don't need it. Yeah, no. Thank you for giving me homework. I gave it to you. That's my turn, right? So when I grade the homework, I'm grading, what'd you turn in? 4 problems? I grade all 4 problems out of 10. So break, another 6 minutes for break, if you need it. What's up, Captain?
What was the difference with the question you did here and the one you did in the beginning?
The one I did in the beginning was a radical, right?
I thought the one you did in the beginning was also like the same homework question.
Oh, yeah. The difference in that one is I'm finding a slope at a specific point. This one, I'm finding the derivative. It's at every point. Yep. All right, we've got a new topic today. We've got to talk about continuity. We've only got really 2 topics left in chapter 2. Continuity and limits involving infinity. So we're talking about homework 5 here. This is section 2.5, continuity. So continuity is pretty obvious, right? What do you think? What do you think about it? Pretty obvious that this is continuous. There you go. That's all I need. No holes. Right? So G is not continuous. And this is the smallest version of not continuous that we would want to be talking about. Any kind of jump is trouble, right? A jump discontinuity is trouble, right? Right, this is a pothole in the road, yes? It hurts a little bit, not much. But if it was a big cliff, like a bridge collapse, right? We don't even have a limit in that case. Right, is that making sense? If it's a big jump discontinuity, I pick my epsilon in between, right? And this one, I get a limit, don't I? This one I get a limit, don't I?
Yeah.
Because when I do the limit, I don't care about getting to the hole. Right? So continuity is simple. I need to be able to fill in the hole. Right? So we'll say that F is continuous at x equals c if and only if, meaning this is the definition of it. What I'm saying leads to my next line, and my next line leads to the first line, right? The limit as x goes to c of f of x is f of c, and that's a real number. Remember what we were doing to get a replacement function, right? What were we doing? We were getting something that I could plug in, right? So that's what I'm saying. I don't even have to get a replacement function if I'm continuous. If this function is continuous, I don't even need a replacement function. I can just plug in right away. So I need to be able to get a limit to show continuity. I need to be able to show continuity to get what? What are we just worrying about right now? We just did a bunch of problems. What are we finding? Derivatives. I need the limit to get continuity. I need continuity to get differentiability. If I can't stand on the hill at that point, how am I going to calculate the slope of my skis? I'm falling. Right? So I need a limit to get continuity. I need continuity to get a derivative. Now what's funny is they don't imply each other, right? The limit, go ahead.
Like in physics, you need the first function, sometimes you use the first function to get the velocity,
Yes, and in that particular function, it's infinitely differentiable, right? If it's a polynomial, I can keep taking derivatives without worry, right? But a limit does not imply continuity, which does not imply differentiability. Just because I have a limit doesn't mean I don't have holes in it, right? Just because I have a limit doesn't mean I don't have holes in the graph, correct? Just because I have continuity, it doesn't mean I get a slope at a point. So, for example, f of x equals square root of x, right? We know what that looks like. Let me turn my mountain upside down for a second, and let me stand up here on my skis. Can you see me? Can you see me shaking? right? If I'm constantly shaking like that, right? How am I gonna calculate the slope? See, if I tip it to one side, right, I've got a negative slope. If I tip to the other side, I've got a positive slope. So not differentiable. But I need the continuity. I have to be able to stand on the top of the hill. If there's a hole there, I fall in.
You can find it.
I can find a derivative. But it does work the other way. If it's diff, it's continuous, and there's a limit. And this is the perfect kiddie hill, perfect kiddie ride. Everything should be nice and smooth. All the turns are nice and smooth.
Is that there's just not a slope right there at all?
Exactly. Well, again, I've got to stand still for you to calculate the slope, and right? You can see me. I have the shakes. I'm trying to balance on that point, right? I can't do it. This is the main thing we're taking out of this whole thing I'm talking about. Just want to talk about how do I show something is continuous or not? And then how can I make things continuous? Those are our two problems, right? So one, show a function is continuous or not. To find a connector function. Those are my two problems. There's a whole section in the book here in 2.5 about is this function continuous or not? Do those. And you'll see there's a whole section of them, maybe 12 problems, maybe 18 problems. It says show that is this function show this function is not continuous, and then there's another set that says show it is continuous. So what's my process? Step one, f of c exists, and it's a number. Find a connector function. You'll understand it. You'll get it when I talk about it. You'll see it. What I mean. Step two: find a limit as x goes to c of f of c. Show 1 and 2 are equal. And we want to do them in that order. Make sure the function can be plugged into and you get a number. Right? Make sure the function can be plugged into and you get a number. Make sure the limit exists, you get a number. Left and right have to be the same, right? And then show that there's two results of the same. So it could fail at any of those steps, and this is the most logical process. First, plug it in. If it fails, done. It's not continuous. Plug it in, fine. Find the limit. If there's no limit, not continuous. Plug it in, find the limit. If they don't match, not continuous. Right? And the other one, and the other type of problem, and I'll do a bunch of these, okay? And the other type of problem, I'm going to give you some functions in like pieces, right? So I might say, find the red function. For continuity. And typically I want both of those on the midterm. For sure, both will be on the quiz. And then everything I give you on the quiz will show up on the midterm. Right? That's the idea. Is that if you do the homework, do the quizzes, and all the other stuff, should be ready for the midterm, right? If you don't do the homework and then you fail the quiz, make sure you can do the quiz for the midterm, okay? The red function. Yeah, it'll make sense when I do problems. It doesn't make sense right now. I tell you, come over later when you see the building with a big yellow M on top, turn right. Doesn't make sense till you get there, right? And then you realize it's a McDonald's. All right, let me do a couple of problems. So there's a whole bunch of problems in the chapter 2 review, old tests, all of that. Let's just do a couple here from the book first. Oh, it's 2.4, sorry. Let's take a look at 16. So explain why we're discontinuous at A. Right? C is 1. Same thing, right? Most of these turn out to be piecewise functions, so don't be a hater. You can also graph piecewise functions on your calculator. Again, do a Google search, how to graph a piecewise function on TI-83, TI-84. I'll show you on Desmos today. So I've got the function x squared minus x over x squared minus 1 if x is not 1, right? And then I've got the function 1, the height of 1, when x is 1. Right? You with me? Correct, but we're going to do a limit, right? We don't care about, in the first part, we don't care about getting to 1, right? Because what does it say the domain is? Not equal, right? Not equal to 1. So I can do a limit there, but I can't plug it in, right? But when I plug it in, which function do I use? The first one or the second one? The second one. Let's take a look at the graph first, okay? I have x squared minus x over x squared minus 1. Did I close my Desmos? I guess I did. It's okay. So I'm going to say y equals x squared minus x, all divided by x squared minus 1. And I want x not equal to 1 is pretty hard for me to show, but I definitely know that I have the point 1, 1 as my other function, right? Oops, sorry. Not 1, 1. Yeah, no, that is what I want. So there's actually a hole in the graph at 1. Yes, you with me? So what do you know right away? Is there's a hole here. And I like to think of it as a manhole cover right off the road. So that if you walk over that hole, you pull in, yes? And I'm always trying to plug up the holes, right? What is a manhole cover round? Why isn't it called a human hole cover? It's a manhole cover, but why is it round? It's the only shape that if you pick it up, no matter how you turn it, it won't fall in the hole. If it was a square, you could turn it on the diagonal, it would fall into the hole. So we already know this thing is discontinuous, right? So the graph is a nice way to tell. But let's go through our process. Yes? So I've got f of x equals x squared minus x over x squared minus 1 if x does not equal to 1, and it's 1 if x equals 1, right? So what, first step, f of 1, what is it? When I plug in 1, I use the second machine, yes? And what do I get? 1. That's a real number. Good, that's what I wanted, I checked. Right? Now I have to look at the limit. So that's step 1, right? I want to look at the limit as x goes to 1 of x squared minus x over x squared minus 1. This one is easy enough for me to not care too much about doing my replacement function. I can do it pretty quick, right? Yes? So I'm looking at the limit. Did I make a mistake there? Oh, yes, thank you. X plus 1, x minus 1, right? So the limit as x goes to 1 of 1 over x plus 1. Sorry, x over x plus 1. Let me slow down a little bit, Robert. Slow down, Robert. So I'm doing my limit, right? Factoring as an x, factoring the polynomial. Cancel the x over x plus 1. And now I can plug in. Notice when I plug in, I'm not writing my limit function anymore. I'm not writing using the limit notation anymore. Get one back. Is that a real number? Okay, so it didn't fail on step 1 or 2 yet, right? But in step 3, 1 does not equal 1/2, so not continuous. Pretty simple, right? So there's a bunch of problems there. So 14 to 18, try a few of them, right? Yeah, I'll go right back. And then like 31 and 32, it says show they are continuous, right? Same process. And then I think your homework problems are 33 and 35. I don't remember. I didn't write them down yet because it'll be next Tuesday. They're not the Tuesday next week, right? This Tuesday is just derivatives coming up. The following one will be continuity. Pretty simple, right? Need the function to exist, need the limit to exist, and the median to match. Do you want to do another one? Like this? Sure. Everybody ready? No? So pretty simple process. Plug in the value you're interested in, find the limit, see if they match. Really simple, right? Graphing helps too, right? Okay, here we go. I guess 17 is fine. We're interested in the limit at 0. We can cheat this one a little bit, right? Don't you think? I don't have to do it all, do I? No, hard to see it. Cosine. If x is less than 0. It's 0, which x equals to 0. It's 1 minus x squared if x is greater than 0. So where do I get the function? Where do I get the height of the function when I want to plug in 0? Which machine do I do it in? I think that's such a horrible picture. Can I do what?
Like close up on 17 origin.
That better? Not really, right? Oh, there, yeah. So which machine do I use to find f of 0? This one, the middle one, right? So I know I have the point 0, 0 on this particular function. So what's cos of 0? 1. What's 1 minus 0 squared? Okay, my limit exists. It doesn't match the height at the point. No. Let me show you that one on Desmos, okay? Cos of 0 if x is less than 0. So I do cos of x space curly bracket x less than 0. So you see it's only showing my cosine left of 0. Then I had the point 0, 0. And then I had 1 minus x squared, right? So y equals 1 minus x squared for x greater than 0. Okay. So I'm on the red curve, and then there's a hole, right? I can push that hole up to 1, I'd have continuity, right? If I put the manhole cover on. Is it differentiable there? It's hard if you don't know the shortcuts. What's the derivative of cosine? Do you remember?
Negative sign.
Negative sign. So what's negative sign evaluated at 0? 0. What's the derivative of 1 minus x squared? Negative 2x. What's negative 2x evaluated at 0? So do the slopes match up? So if I could stand on this hill here, and I can't, I could measure this piece, the slope of this piece. Right? But because there's a hole in the curve, I might fall through. But if that point existed, if the point 0, 1 existed, it would be differentiable. All right, let's do the more interesting type of problem. To find the missing function to connect everything, right? Make something continuous. And there's just a whole bunch of these problems to practice. Look at all my old tests. I had some that are very difficult, some that are simple. I'll start with a nice simple one here. Here's my function. X is equal to, give me a second. It's 1 if x is greater than or equal to 2. It's negative 1 if x is less than negative 1. And it's ax plus b between negative 1 and 2. So I want this graph to be continuous. I don't want to walk along it with no holes, right? What to do? Oh, yeah. Thank you. Oh, I'm having a good day. There we go. Thank you. So you can see, I've got three pieces, right? It's usually a piecewise function, these things. If you hated those in pre-calc, get over it. It's not difficult. Just gotta be able to graph all three pieces, and I can cheat it, of course, right? So I'm gonna graph the pieces I know first, right? So -1 and at 2. At -1, I've got a height of -1 and it's exclusive, right? There's an open hole there. Yes, you with me? At 2, it's inclusive and a height of 1, right? So this is kind of y1, y2, y3, right? So this is y1, this is y3, yes? And what do I want to do? I want to connect them. And what am I connecting them with? Well, y equals mx plus b. And obviously it will connect, right? And when I do this new function, right, I'm filling in the hole on the left, and I don't care about the hole on the right because it's already covered, right? You with me? I need this one to fill in this hole, and I don't care about this one. That hole's already filled in. You get the idea? Who's got an idea for me? What can I do? Well, the slope is easy, right? Don't I have 2 points? What's the left point? -1, -1, right? And what's the right point? 2, 1, yes? So the slope is 1 minus a -1 over 2 minus a -1. So it's 1 plus 1 over 2 plus 1. It's 2/3. Yes? Now I have to find the v value. So I get y minus 1 equals 2/3 all times x minus 2. Where the hell am I getting that from? Yeah, equation of a line, right? With a slope and a point, right? So y minus 1 equals 2/3 x minus 4/3. Y equals 2/3 x minus 4/3 plus 1. So y equals 2/3 x minus 1/3. So A is 2/3 and B is -1/3. Make the function continuous. Then on the test, what am I going to do, or on the quiz? Graph it, right? Y equal to 1 for x greater than or equal to get the greater than or equal, not that it really matters, but there's a little symbol in there, greater than or equal to 2. You can't really tell whether it's continuous or not, right? And then, I mean, you can't tell if the end piece is there or not, but we know by the equal sign. And y is equal to -1 for what, x less than 1? Less than -1, right? And then what did I get from my slider? I got, well, I can just put in y is equal to ax plus b between -1 and 2. Right? So those are with random b values, but what did I get for b? So -1/3 I got. And then what did I get for a? 2/3? Boom. The differential at -1. Can I stand there? Which way are my skis? Not differential. Right? Because when my skis on this side are up the hill and my skis on this side are flat. The same slope, right? Not differentiable, right? Continuous? Let's see if my definition of continuity holds up for this picture, okay? Let's see if my definition of continuity holds up. So show f is continuous everywhere, right? And what did I have? F of x, I had 1 for x greater than or equal to 2. I had 2/3 x minus 1/3 between -1 and 2, and then I had -1 for x is less than -1. So obviously I have to check two places. Yes, you with me? You can see why I skipped this third because it's so boring. I like doing the derivatives. The derivatives are cool. So, but look, we got to check two places, right? What two places do I have to check? Yeah, I have to check at the two connectors, right? If there are three connectors, I'd have to check at all three connectors. So I have to do my definition of continuity twice. I have to plug in, I have to check the limit, make sure they match. I have to do that at 2, and I have to do the same thing at -1. So let's just work at x is 2 first, okay? When x equals 2, what's f of 2? Which, yeah, it's 1, right? It's pretty clear that I have to plug into this machine, is it? Pretty clear that I have to plug in here. That's when I'm allowed x and I use this machine. And I'm sorry, I'm allowed 2, right? At this machine, I'm not allowed 2. Yes, you with me? I'm looking at which machine I'm allowed to use at 2, right? Which piece of the function? So now what do I have to show? I have to show that the limit as x goes to 2 of the other piece is equal to what? Yep. Is that clear? Remember, I'm plugging in the function, then I'm checking the limit, and I'm checking they match. And I'm doing that all at once. Plug in the function, checking the limit, and making sure they match. So what do I get here? I get 2/3 times 2 minus 1/3 equals 1, question mark, right? 4/3 minus 1/3 equals 1, yes. So I'm continuous at 2. Now, is everyone going to be a line in between? No. Usually when it's not linear between, you'll get a system of equations. Make sure you practice some of those. right? We should probably set one up maybe, right? And then go home. So the process at -1 is the same, right? Do you want me to do the process at -1, or are you okay there? One more time, do I, just a little louder for me. Yeah, and a 3-step process. Find the function at the point. Right? Find the function at the point. That's who I'm gonna use that function. Find the limit, make sure they match. Sorry, find the limit, make sure they match. Right? Let me open it. Let me do a pretty nasty one, and then we'll quit. Is that all right? We got 25 minutes left. 10 more minutes, and then we'll quit, okay? Am I right? Yeah, 11:15, yes? You have 25 minutes left. Ah. There we go. What? What the heck? There it is. Where is my damn... I hate this Blackboard on this Surface Pro. Ah, there it is. How do I get it? How do I get that menu? On the arrow, it's supposed to give it to... Oh, there it is. The pen was screwing up. Let's see, chapter 2. Let's go back to fall 2019. Number 10. I've got a 2-piece function. Part of it is linear, right? And part of it is quadratic. It's linear in between -1 and 2. It's quadratic otherwise. Right? So, when I'm doing these by hand, like if I'm doing this on the test and I know what everything looks like, I don't bother graphing it in the calculator. I'm just going to cheat it, right? So I know what so what did I have? I had f of x equals ax plus b, did I say? And then x squared, right? So it's it's quadratic otherwise. And then between -1 and 2. And is it inclusive? Yeah, both inclusive. So -1 and 2, I could have some line like this, right? I don't know. Yes? But what I'm really interested in is what is the quadratic look like at those points, right? So at 1, it hits a height of 1. It's going to be an open circle, sorry. And at 2, it's a height of 4, right? Can you see it? You see the quadratic? Yeah? And then there's some segment in between, but I want them to match up, right? Now I could do this one just like I did the first one, but let me do it a different way, just to give you another option. Let me go right to my definition and see if I can get things to match up, right? So I've got to get it to match up twice, correct? So let's work at 2. What is f of 2? Which machine do I use? The linear or the quadratic? The linear. So I get 2a plus b. Remember, I'm plugging into what value? Into what variable? At 2, right? I'm plugging into x is 2, so 2a plus b. And what, and what height should I hit there? The limit of, as x goes to 2, of what should be 2a plus b? What function am I talking about when I'm doing my limit there? I'm using the first function when I'm at 2. What function do I use when I'm getting close to 2? X squared. So the limit of x squared should be 2a plus b. So what do I get there? What's the limit of x squared? 4. So 4 equals 2a plus b, or better yet, I can leave it like that. 4 equals 2a plus b is fine. But you see here, I'm going to get a system of equations. Let's do the same thing at x is negative 1. What do I get for my f of negative 1? Yep, negative a plus b, right? And I also want the limit as x goes to negative 1 of x squared, and that should equal minus a plus b. I need those things to match up, right? I need the limit to equal the actual height of the function. So what do I get here? 1 equals negative a plus b. I've got my system of equations to solve now. I got my system to solve. You remember the fun you had in Algebra 1 solving systems of equations? Either substitution method or elimination method. I like elimination method. I'm going to negate that whole second equation. 4 equals 2a plus b, negative 1 equals a minus b, and then add them together. 3a equals 3, so a is 1. Yep. So 4 equals 2 times 1 plus b gives me b equals 2. Done. Could I have done that one with a line, just getting the mx plus b from the line? Yes, but some you can't. That's why I wanted you to see me do it with both ways. If I'm looking for a line, I can use the line. If I'm looking for a curve, I might not be able to. There's another one like that in the old tests. Oh my God, so boring, sorry.